Okay, in this video, we're going to solve this problem right here, and so let's begin. So this is a very long problem, so I'm not going to do it by hand, so I have it all typed out. And this problem is going to involve trig substitution. So we start off, this is our reference. So if you have the square root a squared minus x squared, we would use x is equal to a sine theta. If you have the square root of a squared plus x squared, then you're going to use x is equal to a tan theta. And ours is very similar to that, so that's the form we're going to be using. So if I say that a squared is equal to 25, then a is equal to 5. And if I say that u squared is equal to 36x squared, then u is equal to 6x. Then I'm going to swap here. So I have a squared plus x squared. So we have to use x is equal to a tan theta. So now we're going to swap. We have 6x is equal to 5 tan theta. We want to isolate for x, so divide by 6, and x is equal to this. Then we're going to take the derivative of this piece, and so the derivative of tan theta is going to give us secant squared theta, d theta. And, well, we'll call this step 3 and 4. So step 3 and 4. So we want to get theta by itself. So what we're going to do is isolate tan theta. And so we're going to multiply by the reciprocal of this piece. So we get 6x divided by 5 is equal to tan theta. And to get theta by itself, do tan inverse or arctan. And we're going to get this piece right here. Next, we're going to swap x with this. And we're also going to use our dx part. So this x right here, I replaced it with x right here. This dx, I replaced with this piece right here. So we're going to square. 5 squared is 25, 6 squared is 36, tan squared theta. And then we're going to clean up a little bit. So 36 divided by 36, they cancel out. And that's why we have this piece right here. Then I'm going to take this 5, 6, I'm putting it in the front. And also, I'm factoring out a 25 for this piece right here. Now, tan squared theta plus 1 is equivalent to secant squared theta. So we have the square root of 25 secant squared theta. So the square root of 25 is 5. And the square root of secant squared theta is secant theta times our secant squared theta d theta. Now this 5, I'm going to connect here. So 5 times 5 is 25. So I have 25 divided by 6. And secant theta times secant squared theta gives us secant cubed theta, d theta. At this point, I'm going to split up again, and now I'm going to use integration by parts. So u is equal to secant theta, dv is equal to secant squared theta, d theta. And so the derivative of secant theta will give us secant theta, tan theta, and the integral of secant squared theta, d theta, will give us tan theta. So now we use the integration by parts formula, and now we swap. So this 25 divided by 6, it was already here, so I'm going to keep it. And now we're swapping, so u times v. So u is secant theta, v is tan theta. That's why we have it right here. Minus the integral of v is tan theta, times du. du is secant theta, tan theta. So tan theta times tan theta is tan squared theta. But we're still going to need more space. So this part right here is a copy from the last slide. So it's identical. From here, I'm breaking it down. So I'm going to keep my secant theta times, instead of saying tan squared theta, we know tan squared theta is equivalent to secant squared theta minus 1. From here, I'm going to use the distributive property. So this 25 divided by 6 goes to every single piece. That's why it's everywhere. Likewise, negative secant theta times secant squared theta gives us a negative secant cubed theta. And negative secant theta times negative 1 gives us a positive secant theta. Now this is something special right here. This is the same as this piece. So what I'm going to do is I'm going to add it on both sides. So I have 25 divided by 6 plus 25 divided by 6 is 25 divided by 3. And so we can get rid of this piece. And everything else is the same. Now the integral of secant theta is the same as ln, the absolute value of secant theta plus tan theta. So from here to here, swap. And again, this line was the same. So if I want to isolate secant cubed theta, so I need to get rid of 25 divided by 3. So I'm going to multiply everything by 3 divided by 25 in order for it to cancel out. And 25 divided by 25 cancels. 3 divided by 6 gives us 1/2. And this is the same, that's why we have another 1/2. So this is what we have so far. So the integral of secant cubed theta d theta gives us this piece right here. So now we need to go back to the original equation. And so our original equation was 25 divided by 6 times secant cubed theta. So I'm going to multiply this entire piece by 25 divided by 6. And, 1 times 25 is 25, 2 times 6 is 12, and so we get this. Now we need to apply what we saw in the beginning with theta. So earlier we said theta is equal to tan inverse 6x divided by 5. And we also said tan theta is equal to 6x divided by 5. Because we don't want our answer to be in terms of theta. We said tan theta is equal to 6x divided by 5. So tan theta, so tan is opposite over adjacent. So opposite is 6x, adjacent is 5. And the hypotenuse, you do your square root, you do 6x times 6x, so 36x squared. 5 times 5 is 25. And now we're just swapping, because our answer is going to be 25 divided by 12 times secant theta. Instead of saying secant theta, we know secant theta is hypotenuse over adjacent. We know tan theta is opposite over adjacent. And likewise, secant theta plus tan theta. So I'm swapping. And hypotenuse we're saying is this piece. Adjacent we're saying is our 5. Times opposite is our 6x divided by our adjacent is 5. So I'm just swapping hypotenuse adjacent, opposite adjacent, and this is what we have so far. Now we can always simplify. Now 5 times 5 is 25, which cancels with this 25. So then we have 6x times this piece divided by 12. Now here we have a common denominator of 5, so I just put divide by 5. Likewise, 6 divided by 12, the 6 will cancel. The 12 becomes a 2. So we have x divided by 2. Now from here to here, I'm applying my log rule. So like for example, log parentheses 3 divided by 5, that's equivalent to saying log parentheses 3 minus log 5. So instead of dividing by 5, I'm just splitting it up. And that's just a log property. So this is what we have so far. Now this piece right here, it's just a number, so it's like a constant. So instead of saying minus constant plus a constant, just say plus your constant. And this right here is your final answer. A very long problem, and that's all we need to do for this problem.